Good evening, my YouTube viewers. It's Crystal here. I'm just here this evening because I want to give you another code review. This code review is going to be on the mortality rate. It's going to be on Tensorflow, so it's going to be regarding an LSTM, a BiLSTM, a GRU, and a BiGRU. And so basically what we're going to be focusing on in the blog post that I'm going to be making after I make this video is GRUs and BiGRUs. So a GRU is a gated recurrent unit, and it's a type of recurrent neural network that alleviates some of the problems of regular neural networks. And a BiGRU is a bidirectional GRU. So a bidirectional GRU or BiGRU is a sequence processing model that consists of two GRUs, one taking the input in a forward direction and the others in a backward direction. It is a bidirectional recurrent neural network with only the input and forget gates. And if you want to know what a GRU is, we'll look up GRU as well. Gated recurrent network. A GRUs are a gating mechanism in recurrent neural networks introduced in 2014 by Young Chow et al. It is like a long short-term memory LSTM with a forget gate, but has fewer parameters than the LSTM as it lacks an output gate. GRU's performance on certain tasks of polymorphic music modeling, speech signal modeling, and natural language processing was found to be similar to that of LSTM. GRUs showed that gating is indeed helpful in general, and BiGRU's team came to no concrete conclusion on which of the two gating units is better. So that's a GRU. It is a type of recurrent neural network. So now that we know what a GRU and a BiGRU is, we'll go ahead and carry on with the code review because that's what we're going to be focusing on in the blog post that I'm going to be making. So the first thing that we want to do is we want to create a Jupyter notebook, and we have created the Jupyter notebook using Google Colab, which hosts the Jupyter notebook with Google. And so Google Colab is really good, except for the fact that it doesn't have a very good undo function. So you need to be very careful that you don't accidentally overwrite or delete any valuable code. And I have actually done that before. So the first thing we do after we create our Jupyter notebook is we're going to import our libraries. And the libraries that we're going to import is pandas as PD, so that creates your data frame and processes your data. We're going to import NumPy as NP, and that creates NumPy arrays and makes numerical computations. We're going to import sklearn, which carries out machine learning functionality. We're going to import Tensorflow, which creates the neural network. We're going to import matplotlib.pyplot SPLT, which visualizes the data. And we're going to import Seaborn as SNS, which statistically visualizes the data. And then after the first thing you need to do is you need to find out which version of Tensorflow you're using. And the reason why is because Tensorflow has a lot of versions to it, and as a result of that, a lot of their code is deprecated. So you need to know which version you're working with, and I'm working with version 2.12. And then after we have imported the libraries, then what we want to do is we want to set up the random seed with Tensorflow, and that makes sure that you get the same result after each time running the code. And on the programs that I've written that I haven't set up the seed, I've noticed you get a different outcome each time. So it is a good idea to set up your random seed. And I set it up for 42. Now what we're going to do is we're going to use a mortality CSV, and I got the mortality CSV off of a GitHub account, and it's the world mortality rate. The reason why I decided to check on the mortality rate is because I was looking at YouTube videos, and when I was looking at YouTube videos, they're saying that the mortality rate has been increasing, and they believe that this increase in the mortality rate is a result of the recent pandemic we've had. But regardless of the reason, we do have an increased mortality rate, or that's what they say, that we have an increased mortality rate, and I wanted to check it out for myself. And there's actually 150 countries covered in this data set, but I'm only going to be focusing on one country, which is the UK, where I'm living. But you can focus on any country that you want. You don't necessarily have to do it with the UK. You can do it with your country and see what you get. So on this particular data set, we have the year and then the time. And then so what I did was I created a column called year time, and then what I did was I added the time to the year. So that's what we did. So we've added the time to the year. And then so now what we've done is we've set the year time as the index. So now our year time is our index. Now what we've done is you can see which countries you have in the data set, because I've created a set of all the countries, and I picked the United Kingdom, but you can pick whichever country you like, and there's 125 countries to choose from. So in order to pick the United Kingdom, what I did was I filtered out the UK, and I called it UK mortality. So this is your UK mortality. So, and you can see that they check the mortality rate on a weekly basis, whereas some of the countries, they check the mortality rate on a monthly basis. So I decided to make this data set univariate and use the deaths. So UK mortality equals UK mortality deaths. So you can see what it is. So it checks it the year time, and you can see that. We don't have any null values, but just in case there were some null values, we use pandas to backfill the null values. But fortunately, we don't have any. But I left that code in there just in case. Now we're going to visualize the data. This is a visualize the data from weekly from 2015 to 2020 to 2023. And you can see that there are a lot of spikes. So that means you had more death some weeks than you did others. And then on one of the biggest spikes was around 2020, which was when we had the coronavirus. And then the second biggest spike was 2020 or 2021. And then you had another spike on 2022 or 2023. So we've had the three biggest spikes as a result of the coronavirus. And obviously, I can't say whether it's the result of the coronavirus. All I can do is say that we had these spikes. So now what we're going to do is we're going to split the data into training and validating sets. And so the training set is going to be 90% and the validating set is going to be 10%. And then so what I wanted to do was, I wasn't sure because they're saying that we have an increase in deaths, and I wasn't sure about that. So what I did was I did use the describe to check the statistics of the trained data and then check the statistics of the test data. And then I looked at the mean. So the mean of the trained data was 12,044 and the mean of the test data was 13,255. So I think that based upon the means of the trained data and the test data, that the number of deaths has increased. That's just my humble opinion when you look at the statistics and you check the means. So now what we're going to do is we're going to use sklearn's min-max scaler to scale the data. So we scaled the data on the trained scaled and the test scaled to make the data from values 0 to 1. And then, so we're going to make the data 0 to 1. And then after we scaled the data, and remember that at the end of the program, you have to inverse what you have done. So don't forget that. And then after we've scaled the data, we're going to create the data set. And we create the data set by we create an X and then a Y. And then we use a for loop to create an X value and a Y value. And then, so you've got your np.array XS and your np.array YS, which is your data set. So X train Y train equals create data set train scaled 1. X test Y test equals create data set test scaled 1. And so you can see the shapes of the data set. Now what we're going to do is create the models, and the only thing that we're really going to concern ourselves with in this particular code review is the GRU. That's the gated recurrent unit. So we're going to create a GRU, which is a gated recurrent unit, and then we're going to create a BiGRU, which is a bidirectional gated recurrent unit. So in the GRU, you have model.add GRU units equals units, return sequences equals true, input shape equals xtrain.shape1, and xtrain.shape2, model.add dropout, and then you have your hidden layer of model.add GRU units equals units, and then another dropout layer, and then a dense layer. And then we're going to compile it with optimizer equals atom and loss equals MSE. And the bidirectional GRU is a little bit different because you add the bidirectional wrapper to it. And what the bidirectional does is it adds, you've got two GRUs, you've got one GRU going in the forward direction and then another GRU going in the backward direction. And then other than that, it's made exactly the same as the GRU. So now what we're going to do is we're going to train the model. So we're going to define a function to fit the model. We're going to set up early stopping. Keras equals keras.callbacks.early stopping. Monitor equals valve loss. Patience equals 10. And then you have history equals model.fit. Xtrain, Ytrain, epochs equals 100. validation split equals 0.1, batch size equals 16, shuffle equals false, callbacks equals early stop. And then it's going to return the history. And so we're going to fit the GRU and the model GRU and the model BiGRU. And so you can see all the data here has been trained. And then so we check our model performance. So you can see that the loss is very low on the GRU and the loss is very low on the bidirectional GRU. Now what we're going to do is we're going to make predictions on the data. So the first thing you want to do is you want to transform the data back to the original data space. So ytest equals scalar dot inverse transform ytest, ytrain equals scalar dot inverse transform ytrain. And then now we're going to make predictions on the data. So def prediction model, prediction equals model dot predict x test, prediction equals scalar dot inverse transform prediction, and you're going to return your prediction, and we're going to predict on the data for the GRU and the BiGRU. And then what we're going to do is we're going to plot the test data onto a graph, so you can look at that. And then after we have plotted the test data onto a graph, you're going to calculate the MAE, that's the mean absolute error, and RMSE, which the root mean squared error. And when we do that, we evaluate the prediction with the GRU and the BiGRU. So you can see the GRU has an RMSE of 1651 and the BiGRU has an RMSE of 1656. So that means that the GRU RMSE is better than the BiGRU RMSE. So that's worth noting. And now what we're going to do is you can see how we plotted the test data onto a graph, and you can see that we plotted the test data and the prediction. And you can see that with the BiGRSU the GRU and the BiGRU. And now what we're going to do is we're going to visualize the predictions. And so you can see that we have visualized the predictions, put the actual data on the graph and overlaid the predictions on top of it for the GRU, and you can see the predictions overlaid on the data, and with the BiGRU you can see the predictions overlaid as well. So that's what we're concerned with mainly, is GRU and BiGRU. So you can see that it's done a pretty good job of making predictions. So that's interesting, and it did a really good job. So I'm going to go ahead and close this video because we've talked about time series forecasting, about the mortality rate, whereas I believe the data that the mortality rate is increasing. It's hard to actually see it on this particular graph because you've got so many spikes. But when I checked the mean of the trained data and the mean of the test data, the mean on the test data was more than the mean on the trained data. So that indicates to me that the mortality rate is increasing and you have more deaths. So that's something to think about. And there's a lot of speculation about the reason for these deaths. And obviously, I can't talk too much about that because YouTube doesn't really like us talking too much about the reasons for the increased mortality. But the only thing I can say is that we do have increased mortality. And it's up to the professionals to resolve those problems. So I'm going to go ahead and close this video. Thank you to my subscribers for supporting my video. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. Thank you so much for watching this video, and I look forward to making more videos for you in the future.